All right, let's dive deep into mechanical engineering today.
Sounds good.
We're using Indeed.com's career guide to guide our deep dive.
Okay.
Now, our listeners are pretty familiar with the field, I think, so
Right.
we're going to go a bit beyond the basics.
Okay, yeah.
Try to uncover some of those, like, aha moments.
For sure.
Maybe even spark some ideas, get those gears turning.
Yeah, I think what's really fascinating about mechanical engineering is just how much of a foundation it is for, like, so many things in our world.
Yeah.
From, like, your everyday stuff to, like, the crazy cutting-edge stuff, you know?
Right.
It's really where the principles of physics and mathematics and materials science all come together to create the machines and systems that we rely on.
Okay, so we all know about car engines.
Sure.
We all know about our HVAC systems.
Right.
But give us an example of where mechanical engineering gets really mind-blowing.
Well, I think one area that's just, like, absolutely incredible is nanobots in biomedicine. These are, like, tiny little robots that are designed using these principles of mechanics and materials science, and they could revolutionize, like, drug delivery.
Oh, wow.
So imagine targeting medications directly to, like, cancerous cells or repairing damaged tissue, but at a microscopic level.
Yeah.
Like, that's the future that mechanical engineers are working toward.
Nanobots traveling through our bloodstream?
Yeah.
That's incredible.
That's wild.
So the Indeed guide mentions all sorts of subdisciplines within mechanical engineering.
Right.
I'm curious about kinematics.
Okay.
That sounds more like physics to me.
Yeah, you're right to see the connection. Kinematics is all about the science of motion. But in mechanical engineering, we're really focused on applying that to design systems that move with incredible precision and efficiency.
Right.
So think about, for example, a robotic arm that's used in manufacturing.
Okay.
It needs to move super smoothly and accurately to assemble, like, delicate components.
Right.
And so mechanical engineers use these kinematics principles to calculate, like, the exact angles and speeds and forces that are required for each movement.
So it's not just about knowing how things move. It's about designing things to move in a very specific way.
Absolutely. It's that application of those physics principles.
That makes sense.
Yeah.
The guide also mentions all these different branches within mechanical engineering.
Right.
What are some that might surprise someone who thinks it's just gears and engines?
Well, let's talk about power plant engineering. So it's not just giant turbines anymore.
Okay.
With the focus on sustainability these days, mechanical engineers are really at the forefront of designing renewable energy systems. So everything from, like, massive offshore wind farms to, like, the rooftop solar panels that you might have on your house. They're tackling this challenge of creating a cleaner energy future.
Okay, that's pretty inspiring.
Yeah, it's a really cool field.
So speaking of applying mechanical engineering to, like, real-world challenges, let's talk about vehicle engineering.
Okay.
That's more than just cars, right?
Oh, yeah, absolutely.
Yep.
Vehicle engineering, it really encompasses everything from designing high-speed trains that connect cities to developing autonomous drones for package delivery.
Okay.
And, yes, even spacecraft.
Wow.
So those rockets that launch satellites into orbit or carry astronauts to the International Space Station, those are all products of mechanical engineering.
My mind is officially blown.
It's a wild field.
It sounds like all these branches, though.
Yeah.
They overlap with other engineering fields.
For sure.
It's not just a neat little box, is it?
Exactly. It's all interconnected.
Okay.
So, for example, take aerospace engineering. While it focuses on flight, it relies super heavily on those core principles of mechanical engineering.
Right.
So think about, like, designing a supersonic jet.
Okay.
You need to understand things like aerodynamics, thermodynamics, materials science to create an aircraft that can withstand those extreme speeds and temperatures.
Oh, yeah.
It all comes back to those fundamentals of mechanical engineering.
So it's more like a web of interconnected disciplines.
Yeah, I like that.
What about something like biomedical engineering?
Okay.
That seems pretty far removed from, like, designing a power plant.
You might be surprised.
Okay.
Because biomedical engineers are designing all these, like, life-saving medical devices.
Right.
And they rely heavily on those mechanical engineering principles.
Interesting.
So think about, like, a prosthetic limb.
Okay.
It needs to be lightweight yet strong.
Right.
It needs to move naturally.
Yeah.
And it needs to interface seamlessly with the human body. That requires a deep understanding of mechanics, materials, and even like human anatomy.
Prosthetics that move naturally.
Yeah.
I've always wondered how they design those.
It's pretty incredible.
So it sounds like mechanical engineers work on some pretty mind-blowing stuff.
Oh, for sure. Yeah.
But let's get down to, like, the tools of the trade.
Okay.
I'm picturing greasy wrenches and overalls.
Oh, okay.
But I have a feeling it's more high-tech than that.
Well, the overalls might still make an appearance sometimes, but you're right. The tools have evolved dramatically.
Okay.
So computer-aided engineering, or CAE, is now a cornerstone of the field.
So not just blueprints and slide rules anymore.
No, not so much anymore.
Tell me more about the CAE.
So imagine designing a complex engine component, but in 3D, not on paper.
Right.
So you can use CAD software, computer-aided design software, to create these incredibly detailed models, and then you can use what's called finite element analysis to simulate how that component is going to perform under stress.
Oh, wow.
So you can virtually test different materials and
Interesting.
optimize that design before anything physical is ever built.
Wait, so you're telling me they can test designs virtually?
Yeah.
Before building anything?
Yeah, it's amazing.
That's incredible.
It's very powerful.
It must save so much time and money.
Absolutely.
Wow.
And it makes the whole process so much more efficient.
Yeah.
And it also helps to make manufacturing cheaper and more sustainable.
Okay.
Because we can reduce material waste.
Right.
We can optimize performance, and we can even simulate how products are going to behave.
Wow.
In like real world conditions, all within this virtual environment.
That's pretty cool.
It's very cool.
So, someone listening might be thinking, sign me up. I want to be a mechanical engineer.
Right.
What's that roadmap look like?
Well, the journey typically begins with a solid education.
Okay.
So a bachelor's degree in mechanical engineering from an ABET accredited program.
Okay.
That's the standard entry point.
ABET accreditation, got it.
Yeah, ABET accreditation ensures that the program meets like high quality standards.
So it's something to look for when you're choosing a school.
Absolutely.
Now, the guide lists a bunch of different degrees, like a Bachelor of Engineering versus a Bachelor of Technology.
Yeah.
What's the difference?
That's a great question.
Okay.
So a Bachelor of Engineering, or BN, typically focuses more on those theoretical and scientific principles of engineering, whereas a Bachelor of Technology, or B-Tech, often has a more hands-on approach.
Okay.
So it's kind of the difference between like understanding the why and mastering the how.
So if someone's more interested in getting their hands dirty in a workshop, maybe they'd lean towards a B-Tech.
Exactly.
Okay.
But both paths can lead to very successful careers in mechanical engineering. And the choice really often comes down to like individual learning styles and career goals.
I've always wondered what kind of research a PhD in engineering involves.
Yeah, so a PhD in mechanical engineering, that's for those who really want to push the boundaries of the field.
Okay.
So they're the ones developing new materials with incredible properties, designing innovative energy solutions to combat, climate change, or even advancing the fields of robotics and artificial intelligence.
It's where cutting-edge research meets real-world impact.
Absolutely.
So from designing everyday objects to like exploring the frontiers of science.
Right.
Mechanical engineering really does offer a wide range of possibilities.
It's a huge field.
Time for the question everyone's thinking.
Okay, hit me.
Show me the money.
All right. Well, according to Indeed.com, the average salary for a mechanical engineer in the United States is around $85,575 per year.
Okay, but the guide also mentions a range from $28,000 to $166,000 a year.
That's right.
What factors influence that huge spread?
Yeah, you're right. The salary range can be quite broad.
Yep.
And several factors come into play, including experience level, location, industry, company size, and specialization.
So it's not just about getting the degree.
Right.
It's about like building expertise and finding the right niche.
Absolutely.
So let's say you're sitting across from a hiring manager for that dream mechanical engineering job.
Right.
What are they really looking for?
They want to see that you can apply your knowledge to real-world situations.
Okay.
So, imagine they ask you to describe the function of a check valve.
Okay.
Something you might find in like a spray bottle.
Yeah.
It's not about reciting the textbook definition. It's about understanding how it works within a system.
Yeah.
And being able to explain that clearly.
That makes sense.
Yeah.
It's about connecting those everyday objects
Right.
to those underlying engineering principles.
Exactly.
What about a question that really tests your ability to think outside the box?
A classic example is being asked to describe different types of springs.
Springs. Okay.
So it's about going beyond that like basic definition of
Yeah.
a spring and understanding that they come in all these diverse forms and have all these different applications from the gas springs in your office chair to like the suspension system in a car.
Okay, that one definitely requires some creative thinking.
Yeah, it gets you thinking.
So it sounds like acing a mechanical engineering interview
Mm-hmm.
takes a mix of like technical knowledge,
For sure.
problem-solving skills,
Yeah.
and the ability to communicate those concepts clearly.
It's all about communication,
Right.
being able to articulate those ideas.
Awesome.
Yeah.
It's fascinating how this field is constantly like pushing the boundaries.
It really.
We've talked about nanobots,
Right.
but those are just like one example
Yeah.
of the amazing things happening in material science.
Oh, absolutely.
Mechanical engineers are working with materials that are stronger than steel,
Mm-hmm.
yet lighter than plastic.
It's incredible.
Like,
Right?
imagine the possibilities
Oh, yeah.
for building more efficient vehicles or lighter aircraft or even structures that can withstand like extreme forces.
Yeah. It's really mind-boggling.
It's mind-boggling to even think about.
Yeah.
And speaking of impact, I'm curious
Yeah.
about ethical considerations in mechanical engineering with such like powerful tools and technologies at their disposal.
Mm-hmm.
Do engineers have a responsibility to think about like the broader implications of their work?
That's a really important question.
Yeah.
And one that's becoming increasingly important in the field.
Okay.
As mechanical engineers, we have a responsibility to think about
the societal and environmental impact of our designs.
Okay.
So, for example, when you're designing a new energy system,
Right.
we need to think about its carbon footprint.
Mm-hmm.
We need to think about the impact on local communities
Yeah.
and its long-term sustainability.
So it's not just about making something that works.
Exactly.
It's about making something that works in a way that's responsible and beneficial for society as a whole.
It's about finding those solutions that are not just technically sound, but also ethically sound.
Right.
Which can be a challenge, but it's a really important part of mechanical engineering.
That's definitely something I'll be thinking about as I continue to like explore this field.
For sure.
It's fascinating how much depth there is to mechanical engineering. It's not just about those technical skills.
Right.
It's about the creativity.
Yeah.
It's about the problem solving.
For sure.
And now, as we've just discussed,
it's about those ethical considerations.
Yeah, you hit the nail on the head.
Okay.
It's a multifaceted field, that's for sure.
All right, so we've talked about cutting-edge tools like CAE.
Right.
We've talked about ethical considerations.
Yeah.
But let's shift gears for a moment.
Okay.
And talk about like the actual work environment.
Okay, sure.
What's it really like to be a mechanical engineer?
Yeah.
Is it all cubicles and computer screens?
Well, it can certainly involve some time spent in front of a computer.
Right.
Especially during like those design and analysis phases.
Yeah.
But mechanical engineering is far from being confined to a desk job.
Right.
A lot of engineers spend time in labs, testing prototypes, working on hands-on projects, and collaborating with colleagues in a much more like dynamic setting.
So those overalls might actually come in handy sometimes.
You never know. You never know. There's a really there's a very tangible aspect to mechanical engineering that a lot of people find really appealing.
I could see that.
Yeah.
But let's be honest. Engineering can be a challenging field.
Oh, for sure.
What are some of the biggest hurdles mechanical engineers face in their work?
I'd say one of the biggest challenges is just dealing with complexity.
Yeah.
Mechanical systems can be incredibly intricate with
Well,
all these different interacting components and forces.
Yeah.
It takes a really keen eye for detail. a deep understanding of the underlying principles,
Yeah.
and a real knack for problem solving.
Okay.
To be able to navigate those complexities.
So it's not for the faint of heart.
It certainly requires a certain level of tenacity and dedication.
Yeah.
But the rewards are immense.
Okay.
You know, there's a really deep satisfaction that comes from solving a complex problem.
Yep.
Designing a system that works flawlessly, or creating something that truly makes a difference.
Makes sense.
Yeah.
So it sounds like mechanical engineers need to be comfortable with like a constant state of learning and adapting.
Absolutely. You know, technology is constantly evolving.
Right.
New materials are being developed.
Yeah.
And the challenges that we face as a society are just becoming more complex.
Yeah.
So a successful mechanical engineer really needs to be a lifelong learner.
Okay.
Always curious, always seeking new knowledge.
Right.
And always ready to adapt to change.
Speaking of adapting to change.
Yeah.
Let's talk about the future of mechanical engineering.
Okay.
What are some of the emerging trends and technologies that are shaping the field?
I think one of the most exciting areas is the intersection of mechanical engineering with artificial intelligence and machine learning.
So we're seeing the development of intelligent machines that can learn from data, adapt to changing conditions, and even make decisions autonomously.
It's incredible, right?
This has like incredible potential in areas like robotics, manufacturing, and even transportation.
Absolutely.
Self-driving cars are like a prime example of that, right?
Perfect examples.
Like they rely heavily on mechanical engineering principles, but also on AI algorithms to navigate and make those decisions on the road.
You got it.
And the possibilities extend far beyond just self-driving cars.
Oh, yeah, for sure.
We're talking about robots that can assist with surgery.
Right.
Drones that can deliver packages or inspect infrastructure.
Yeah.
And even smart factories that can optimize production and reduce waste.
Absolutely, yeah.
So it sounds like the future of mechanical engineering is all about blurring those lines between the physical and the digital.
Exactly.
As we continue to develop more intelligent machines and systems, the role of the mechanical engineer will become even more critical.
Absolutely.
You know, we need to ensure that these systems are safe, reliable, efficient, and ethically sound.
Couldn't agree more.
Wow, this deep dive has really opened my eyes to the vast scope of mechanical engineering.
Yeah, it's a big field.
From designing nanobots to shaping the future of AI-powered machines.
It's amazing how much it covers.
It's a field that's constantly evolving.
Yeah.
And pushing the boundaries of what's possible.
Absolutely.
Before we wrap up this part of our deep dive,
I
want to touch on something that I think is often overlooked.
Yeah.
When we talk about engineering careers.
Oh, okay.
The creative aspect.
Right.
Many people think of engineering as purely technical.
Yeah.
But it seems like there's a lot of room.
There is.
For creativity and innovation.
Oh, absolutely.
In this field.
Mechanical engineering is inherently creative.
Okay.
It's about envisioning new possibilities. It's about coming up with innovative solutions to complex problems.
Yeah.
And designing systems that have never existed before.
So it's not just about following formulas.
Right.
And plugging numbers into equations.
Well, those are certainly important skills.
Okay.
The heart of mechanical engineering really lies in the ability to think outside the box, to challenge assumptions, and to come up with these novel approaches to solving problems. It's about finding those elegant solutions that are both functional and aesthetically pleasing.
That's a great point.
Yeah.
It's easy to forget that many of the objects that we use every day, from our smartphones to our cars, are not only functional, but also beautifully designed.
Exactly. And behind that design is a mechanical engineer who has carefully considered not only those technical aspects, but also the user experience, the aesthetics, the overall impact of that product.
It sounds like mechanical engineering is much more than just a technical field.
Yeah.
It's a blend of science and art and a deep understanding of the human experience.
That's a beautiful way to put it.
Okay.
Yeah, mechanical engineering is really about using our knowledge and our creativity to shape the world around us, to make it more functional, more efficient, more sustainable, and ultimately more enjoyable to live in.
It's really amazing how mechanical engineering, like, seamlessly blends that functionality with aesthetics.
Yeah, it's not just about making things work. It's about making them work beautifully.
Yeah.
And that brings us to a really crucial point, I think.
Okay.
You know, when we talk about the future of mechanical engineering, we often focus on specific technologies.
Right.
But I think the true driving force behind innovation is the human element.
Yes.
It's the passion, the creativity, the problem-solving skills of the engineers themselves.
So it's not just about the robots and the algorithms. It's about the people behind them.
It's about the people, exactly.
Okay.
It's the engineers who are pushing the boundaries, asking the tough questions, and finding those innovative solutions to the challenges that we face.
This deep dive has really highlighted how multifaceted mechanical engineering is.
It is.
We've covered everything from, the microscopic world of nanobots to the complexities of designing spacecraft.
It's a huge field.
It's clear that this field offers a path for those who want to make a real impact on the world.
Oh, absolutely.
And for someone just starting their journey into the world of mechanical engineering. What advice would you give them?
I would say embrace your curiosity.
Okay.
Never stop asking questions. Don't be afraid to challenge assumptions.
Right.
And most importantly, find a problem that you're passionate about solving.
Okay.
And use your skills to make a difference.
That's great advice.
Yeah.
And remember, you don't have to have all the answers right away.
No, not at all.
Learning is a continuous process.
It is.
And the field of mechanical engineering offers just endless opportunities for growth and exploration.
Absolutely.
Surround yourself with mentors and colleagues who inspire you, who challenge you to think differently,
right,
and who share your passion for making the world a better place.
Couldn't agree more.
Well, this has been an incredible deep dive into the world of mechanical engineering.
Yeah.
We've covered so much ground.
We have.
From the fundamental principles to the cutting-edge innovations that are shaping the future.
Absolutely.
I feel like I have a whole new appreciation for the ingenuity and impact of this field.
It's an amazing field to be a part of.
Yeah.
It's incredibly rewarding to know that your work can contribute to solving, these global challenges, improving lives, shaping a better future.
To everyone listening, if this deep dive has sparked your curiosity, don't let that flame die out.
Keep it going.
Keep exploring.
Yeah.
Keep learning.
Keep pushing those boundaries.
And keep pushing the boundaries of what's possible.
You got it.
Who knows? You might be the one to design the next groundbreaking innovation that changes the world.
You never know.
This is The Deep Dive, signing off next.